Testing audio. Testing audio. Testing audio. Audio is tested. Testing snacks. Snack. Snack supplies nominal. Hello. How's it going? I now have to revert the work I was doing earlier today, because we're going to do it once more with feeling. Once more with feeling. How's it going, everybody? Where everybody is at least two people. So I have not been as much on the internet as I have been recently. So I'm kind of wondering, that Ubisoft thing that happened like yesterday or the day before, I haven't heard anything else about that. So is that like totally just like a false alarm, or like someone prank calling or something? What was the deal with that? 8 days? Has it been 8 days since I streamed? That's crazy. It doesn't seem like that long. It does not seem like that long. I still have that. Yeah, I've been meaning to read this paper still. That's why it's open in the web browser. However, I have read other tabs that are now gone. So I'm working my way through. Nobody knows about the Ubisoft thing. Oh, wait, the Handmade Seattle thing is happening right now? Okay, that's weird. Weird timing. Oh, I know it's this weekend, but I thought it would be over by now for today. I guess I'm on East Coast time, so I'm a little disoriented, but you might want to ask if there might be a way to compile the language to WebAssembly. Yeah, I mean, LLVM can do that, but I just don't... Hold on a second. Looking at the hotel schedule for restaurants and stuff. I just, you know, the focus on WebAssembly, I don't believe is, like, a lot of people are interested in it, but they're interested in it for the same reason they're interested in JavaScript in the browser and stuff, which is just that it's very, like, oh, you can run it in a web browser, but like that doesn't make it good, and it doesn't make it a good idea to double down on that technologically for the future. So, like, oh, the compiler thing is the last talk. All right. Well, I legit didn't know. That's fine. Maybe people can watch this later if they want to go do the compiler talk now. The VOD will be up. I will not. Sometimes I delete VODs, but I won't delete this one. It was a hoax called in by some troublemaker. Well, that sure was a big police response for a phone call. But I guess that's what you got to do these days. Anyway, what I was going to say is I view WebAssembly, the usefulness of WebAssembly is to enable the transition off of a browser and onto more sane, stable platforms than browsers. And if people are excited about it for that reason, then I share the excitement. If they're excited about it because they want to run ever more complicated crap that runs in web browsers, then I do not share in that excitement, right? So it depends on like what you plan to do with it. 8 days. Wow, I didn't realize I was gone for 8 days. Sorry, guys. When I'm traveling sometimes, just things happen and time just flies. Right. Didn't I streamed the day after my birthday, which would have been November 4th. That was 10 days ago, so I guess I did another one after that. You don't think the web will be going away anywhere anytime soon? You think W3 have been pushing the web into the direction of eventually being able to completely replace native apps? They will never be, that will never happen. Ever. Ever. All right, everybody. Apparently, the Handmade Seattle compiler talk is going on now or starting soon. Does it start at 2:30 West Coast time, or like when does it start? Did it start at 2? I don't know. But you have that as an option. I don't know if that's on Twitch. I guess it's streaming somewhere. Somebody can link it in the chat. Like I said, we're just going to be doing regular programming here, so it's not like this is not like a structured talk designed to be a maximum payload densification. So if you want to go see something that is supposed to be that, then there's some conference content for you to go to right now. Abner is streaming it. Okay, there you go. Somebody has linked it. The room geometry is at the Pentagon. It is a weird shape. You are correct. It is not the Pentagon. It is a weird shape. You think it starts in half an hour. So is it like intermission right now? Where am I? I am on Hilton Head Island, South Carolina, enjoying the beach. This island is not owned by Paris Hilton, apparently. I had never heard of it before a few days ago. The beach is not as good as a Southern California beach, but it is better than, I don't know, like a northern East Coast beach. Like it's pretty warm still. It's like 73 degrees out during the day, which means the water is pretty warm too. I didn't go in, but the water is pretty warm too. Abner is still transcoding the podcast. Oh, so it was recorded like really recently. Or someone only just emailed it to him or something. Wait, if you can transcode it, can't you just play it live? I don't know. I don't want to know. I want to focus on my programming task. All right, well, I see a bunch of ASCII gibberish on my phone, but I'm going to assume that is nasty. And I don't know how to do anything good from my... So we're going to go here and we're going to go into followers only mode. for 10 minutes. Correct assumption. All right, I'll try to ban a few of these from my phone. It's just not the best interface for that. All right, hope I didn't ban any innocent bystanders. Do I hold a grudge against web dev because the field is just so saturated with bad, inexperienced programmers? Well, I definitely don't like that that's the case. But no, I hold a grudge against web development because it's ruining programming. That's why. Because it's the worst kind of programming, and it basically set programming back by decades. That's why I don't like web development. Now, it's web programmers' fault that they don't realize that web development has set programming back by decades, and they think it's all like rocket science and stuff. But that's actually a different issue. I mean, look, Call of Duty Black Ops 1980s just came out. What's that game called? It has some 80s name. Boiling Point. Cold War. Cold War, yes. Look at that compared to a website. How much better is Call of Duty Black Ops Cold War than a website? That is my objection to web development. Did Unity set back programming? I think it's in the process of doing that, yes. Call of Duty War. You're a web dev and you know it's bad, but what you can do, you can get a job somewhere outside of web development. All right. Isn't Mike Acton working on Unity now? He's been there for at least 2 years, maybe more. Okay, so I just want to do some programming instead of getting mired in chat forever. Okay, so this compiler talk is apparently happening right now. If you want to go look at that. Or listen to that, I guess. It's audio, or is it video? I don't know. It's probably video if it took a long time to encode, right? Anyway, so somebody can post that link again as well. So I was just going to do some programming because it's been a while. And I actually was going to take today off and not program. But then one of our beta users, so we expanded the beta like a week ago or a little more to double the size. And of course, people are hammering on the compiler harder and just finding tweakier stuff. And this morning I got up and checked my email, and there was a case of polymorphism that I actually broke in the most recent beta, which I shipped last night. I think only one beta user out of all of them ran into it. It's a case that is stressing this current system in a way that is not really friendly to it and could cause a lot of problems. But so then I was thinking about various hacks of how to get around it, and I sort of tried to do one of those earlier today, and it didn't work. And then I took a walk on the beach, and I was thinking about it, and I was like, okay, I think I know what's the right way to solve this. And so I'm just going to work toward that. Like, I have a clean solution for this relatively, I wouldn't say corner case. It's just a hairy thing. It's a thing where the compiler has to do a really good job. I could actually show you what it is. That might help. What's the file called? I probably ran it here. Oh yeah. Okay. So the deal is the following. We just have some thing. It's a main. It's like calling some stuff. It makes an array and it makes these sparse sets. And then it's calling this thing called contains, right? And so contains is overloaded. And it's got two overloads here. This one is the one that we're actually calling, right? This one is not the one that we are calling. And in fact, that's obvious because the arguments don't even match. So the second argument here is an integer, right? This cannot be an integer, right? Now, this is something that we handle most of the time just fine. What we do is we infer the types of just the headers of these procedures, just like you would have a function signature in a functional language, or a function header in C. So we sort of just infer enough to do this, and then we go do the overload resolution process on those, right? Now the problem is with this one, we have a problem we didn't have before that I think only worked in previous betas by luck. And that problem is, it's got some arguments, but then it's got a return value, and this return type is a complex type. It's a struct with parameters that involve this thing, all right? And that engages all this other polymorphism and static ifs and it's heavy duty compiler machinery to generate this. And so we're generating this when we're just trying to infer this function header, even though we're not even using this function, right? We're only using this one. So what we really want to do is just do the arguments and not the return values, because we don't need the return values, especially because we don't do polymorphism by return value by choice, right? So I think that will solve the problem. And then there are questions about how to do that in a way that's clean or not clean. And I'd already started taking polymorphism in a different direction implementation-wise than it had been for a while. And so I'm going to continue it in that way and make it, just try to make it clean and a good solution. And it's just going to be very different from the way it's been. And that might mean there's a lot of restructuring and it doesn't get done tonight, but that's fine. It's the weekend. We're chilling on the beach. Are there any questions about what I just said? We're in 10-minute follower mode, so unfortunately we had some spammers. If you want to ask questions, you can follow, and then 10 minutes later you can ask the question. That's unfortunate. But yeah, from anyone who's been following or subbed, are there any questions about this? Because we're trying to solve this very focused problem. Oh, here's what the problem looks like. So we try to compile this program, and it says we're trying to use this binary operator equals, which isn't defined for a sparse set on each side. It's like, why the hell are we trying to do that? Well, it's while we're generating a polymorph of this struct. Why the hell are we doing that? Well, it was triggered here. Right? And why were we doing that? It was triggered here. So actually, I'm amazed that our error reporting is this good, because this is probably the deepest legit case of polymorphism. Like, it's telling us all the way out. Like, the polymorph was triggered here while we were generating a polymorph of this procedure while doing this. This is exactly what happened with no extra noise and in very readable format. So like, damn, I'm glad about that, because it was an open question when starting to do this programming language about how well would we be able to, like, this error in C++ would be nuts, dude. You would get screens full of spam, as far as I know. Well, depending on the compiler. Actually, is this better in C++ now? Or anyway, so this is great because it tells us exactly what happened and how we got there. What's not great is that it happened, right? Like, It's this part here that is not great. You know, honestly, a little bit of it is weird. So like the highlighting here doesn't include the return value when it is the return value that was the problem. So, you know, there's some little things we could adjust about highlighting and stuff, but for the most part, it's totally fine. I'm in South Carolina. What if one of the parameters has a type as complex as the return type in your example? Wouldn't it trigger the exact problem you're trying to work around? No. Because actually it might. We need to think about that. I don't think that it would. Unless, so the only time that that should actually happen is if the parameters match on the polymorph, all right? If the parameters actually match, then you are liable for compiling that procedure. So if there's an error and the parameters actually match, yeah, you have problems, right? So in this case, the problem is the parameters don't match. And we're still having this problem. Although that said, it is a good point. I wonder if there's a case in which this could be triggered for a parameter. I'm not sure about that. Anyway, so if you look at C++, for dealing with this kind of situation, C++ has this thing called SFINAE, for substitution failure is not an error, which is how they do, you know, this how they work around this kind of problem, but it's a very spammy and very ugly thing. We're much more structured in the way that we do this. So this just shouldn't be happening. Like in C++, this would actually be SFINAE. The compiler would do all this work, and then it would say, oh, it didn't happen. And then it would just silently ignore that overload. That actually makes it a lot harder to understand what's going on as a programmer sometimes. For us, we don't do that. We're very structured and very strongly typed about it. So in a case like this just shouldn't happen, basically, is what we're saying. Generally much better in C++ if you're using a compiler less than 5 to 6 years old. Yeah. Is it heavy to generate the struct because it's heavy, or the implementation isn't optimized? Well, I mean, heavy relative to what? Obviously, compiling one struct in this compiler isn't that slow because we compile programs very fast, right? But how heavyweight is it to compile a struct relative to a function? Maybe it's about the same. I don't know, right? So you're talking about like doubling the expense of compiling a function. So if you do that a lot, then that obviously adds up. But really what I was talking about when I was saying it's heavyweight is that lots of compiler implementation details are involved in doing this, which is involved in doing all that. So it's not exactly about speed, although speed is correlated to number of compiler implementation details. I can actually try that, right? I don't know what you mean by try that. Try what? Why is the use of the binary operator an error there? We don't do equals on structs. That is not a thing that we do. We might do that later. That could be fine. If we did that, we wouldn't happen to get an error in this case, but there would be some equivalent case that would give us an error, right? So we have to solve this problem. You could just say, you know, dereference some member of something down here instead of saying equals. If the parameters matched, you would have already generated the struct. Yes. I mean, again, there's weird implementation details there to be thought about as well. Like this stuff isn't simple. You can actually try a parameter, an example where the parameter is as complex as the return type. Yeah, I just don't want to get derailed right now, because what I want to do is stop introing and go into what I think the solution should be. Because the thing that I want to do has some other benefits. So the thing that I realize about what's happening here is not just that this made an error, but imagine that this body was empty. In fact, let's make it empty, right? Or return true. That might be the only error here. Oh, well, let's import basic. Okay, this is something. That's something that he defined. Okay, so like it compiles if I do that, and it doesn't compile, whoops, if I do this, right? Yeah. So, but the thing is, even if it compiles, we don't want to do all this work in the compiler. Like, we don't want to generate the full type for this overload and generate all this if we're not actually using that overload, right? That's extra work that the compiler shouldn't be doing. And it's a lot, because we're making a struct. That struct has a whole polymorph. That thing has a static if that has to get evaluated, you know, and then we put the right thing in. Like, it's a lot. So we really shouldn't do that if we don't need it. And so regardless of whether this helps us with the parameter thing, I still want to do it because it'll avoid all this work. And as programs get bigger and the types they deal with get much more complicated, this kind of thing tends to matter more. You're quite convinced you can't get away without SFNA when dealing with both overloading and generics parametric types. You're looking forward to see what my alternative is. I don't understand why you say that. I mean, we're fine without it so far. We have a 100,000 line game that doesn't have SFNA. So like, what do you think? Why do you think it's not possible to get around? You're looking for a new keyboard. Which one do I use? I mean, right now I'm using a bad laptop. I can't recommend anything. Can't recommend anything. Here's the thing, guys. Just like everything else in computers, keyboards have not actually gotten better in a long time, that I can tell. They're just different variants. Like the good keyboards have stayed kind of the same. And then there's been more and more cheap, crappy alternatives that feel bad and hurt your hands, right? So you've got to realize that Rome has passed its peak in terms of quality of computer equipment, and you're living in the fall of Rome. So if you ask for recommendations, it's like, I can't. I mean, it's not like there's going to be a good keyboard. You know what I mean? Like, it's not like there's going to be some amazing keyboard that you never saw before, right? The last thing that was trying to be like that was when some dude was like, I'll make a keyboard that has LCD screens on every key. And I forget if that was like a Kickstarter or whatever. That was like a long time ago. It was like 10 years ago. And now people are doing cheaper versions of that too. I don't know. There's just like there's not things. You have a more philosophical question about compilers. It's a compiler's job to give you the information, such as what CPU architecture you are running, what is the cache line sizes, or it's the job of the programmer to know the architecture in which the compiler runs on. Wait, okay, I mean, what you're saying has a very clear answer. That you can think about how it applies to you, right? Actually, no, maybe I don't understand the question. Is the job of the compiler to give you the information? Do you mean give you information like cache line size so that you can use that at runtime? Like so that you compile the thing and it doesn't know, and then you use it at runtime and it dynamically, that's like not going to be fast. Like if you're thinking about cache line size and you think that matters, you need to build the code in advance to be designed for that size. Right? So how can the compiler give you information about a runtime execution environment? Well, you can have primitives or built-ins that return information about that. But of course, you don't get that until runtime, right? Or you can pre-compile every combination of that you expect and sort of have it at compile time. But at that point, you're sort of in a style of code that I really don't like at that point. You mean with some defines or something that is more compile time? I mean, I don't understand then, right? I don't understand the question. Can you suggest a concrete alternative where it matters one way or the other? Where the compiler giving you the defines results in something different than you magically knowing. It's also possible that sFNA is an artifact of the way C++ is. Yes, I think it is that. My claim is it is that. It's actually program. I'm going to make a big mess. Actually, before I make a big mess and break everything, let's make sure the revert fixed it. We want to make sure we're starting in a working state. You'll have less sFNA now that you have concepts. That is true. However, the fact that sFNA is there and has to be supported in order to be backward compatible introduces this very confusing situation where when you have bugs, it's hard to know what's going on a lot of the time. Because it's this very soft fail kind of thing. So that's not good. It would be much better if they had gone back and redesigned the template system to be actually strongly typed. I don't care about integer warnings. Well, I do care about them a little bit. It's just I always find better stuff to do. I've been thinking lately that one of these days I would go hit a couple of the files and deal with the warnings, but you know, could do that some other time. Actually, for For x64 converter and ObjWriter, I had wanted to wait until a really big rewrite pass happened on them, and that pass has now happened. But maybe I'll start with the smaller ones, like, you know, just getting rid of those warnings makes this entire file clean. So maybe I'll do that sometime. Wait, Microsoft craziness.h is in the Swift compiler? That's funny. I hope they patched it to detect Visual Studio 15, because it doesn't. All right. I'm going to have to get a drink. So many snacks today. Okay. So when we do polymorph, well, oh, I forgot to run. We're just going to compile and run the game and make sure the game goes great. How we doing? Oh, look. Look at the game. Why is it running at 15 FPS? Okay. So the first thing I want to do, I have in my head an incremental map of where I want to take this. And part of that, I think I want this source lambda to be on the polymorph progress struct, but I'm also not sure. Like I have this polymorph do progress versus polymorph prep progress. I kind of don't. I kind of don't feel like that's really necessary, although the place where we have the problem, well, let's see, wait. No, okay. No, this is the place where we have the problem. Is the thing that generates that bug is this code right here. So our objective in the short term is to avoid that. Okay, so let me just review. So for prep, we go up here and then we go doing polymorph and final result. And when we're in doing polymorph, we do this. You know, like this could be one struct, I think. If I combine these, am I going to regret this later? I don't think so. think so. I'm just going to convert this and make it work and check it in, just as a simplification. So instead of prep progress, see, I'm trying to remember why I broke this into two things. Like, where aren't these just stored in the same place? Oh wait, I already moved prep progress onto there. So prep progress is gone anyway. There's just do, there's match and do. Okay. We're going to call this do progress for now. Going to get rid of this. Where was our do progress? What? Didn't I just see? Oh, that's on bake. Oh no, right. You know what? I'm going to revert again. My very small number of changes. So I forgot about that. So we have multiple ways of polymorphing a function, right? One is by calling bake. One is by doing the polymorph solve. And that's why these things are split into two right now, is that the polymorph solve right, it has to do, in some hard cases, quite a bit of work to figure out what the parameters actually are. Once it knows it, then it passes them to polymorph do, which is basically the same thing that bake does. Yeah, so I kind of want to leave that part the same as it happens and do it a different way. I think, like, this is a little bit silly, but we might be able to do that later. I think for now, we just let bake do the same thing that it's doing. So who calls do polymorph? This is make polymorph of called procedure, probably. Yep. Okay, that's the struct. This is allocating the polymorph progress in, this is procedure call handling, right? Type check arguments, yeah. This is error reporting. Yep. And this is for handling bake. That's the other location right there. So we just want to let bake do that. That's fine. That's fine. Always be reverting. If you divide a U8 by an S64, does a dividend cast into S64 automatically prior? Yes, so divide wants both numbers to be the same size. So the U8 will implicitly upcast to S64 prior to the divide. How does the implementation look like? I don't know. Is that implemented in the compiler or LLVM? No, it's in the compiler. It has to be. It has to be in the front end. Because, for example, when your metaprogram looks at that divide code, it needs to be able to know what type the numerator is. All right. F. Uh-oh. Are we back? Are we back? Hotel Wi-Fi. Hotel Wi-Fi. We lost some packets, but we're back. Okay. I only have one bar right now. Oh, now we have two. See, oh, there we go, 3. So if you just hover your mouse pointer over the Wi-Fi, it gives it energy. That's back to 2. But it's like, it's like Dragon Ball or something. Is the memory paper good? It's good so far. Okay. What I want to do instead of what I was just doing is I want to this is a little weird. I actually don't understand. I guess I do understand. So the deal is, okay. So there's, if we go into polymorph, this make polymorph of called procedure is kind of this big workhorse that does a lot of things. It does the match resolution that figures out what all the variables are. It has to do default values because that matters. And then this prepping for bake means like, hey, we're gonna pass these things in, right? Okay. Now the thing is, here is sort of the problem, I guess. Right now, what we're doing is we're saying, oh, well, we want to call some procedure. It's maybe got, maybe it's an overload, maybe it isn't, who knows. So let's make the procedure, at least the header of the procedure, and we can use that to type check. And then if we decide to use that procedure, we'll promote it from having just its header compiled to having its whole body compiled, right? And so there are some flags that we have, like when we make one of these polymorph procedures, we say, oh, it's just temporary, don't compile the body. And then at some point later, we say to compile the body and whatnot. Okay. It's a little bit messy now because what we're saying is conceptually, we kind of don't want this whole procedure to be compiled because the return value is giving us issues, right? The return type is giving us issues. But you know what? The only reason why I'm making a full procedure is because that's just kind of what the other code wanted. So what I was thinking was today, if we're really just going to use the arguments, we should just use the arguments. And there is a little bit of a scope relationship. So the arguments need to inherit the constants, right? So they need to be beneath some other block that defines those constants. But that's kind of all that we need to do the type check. And we can just change the type checking code to just look at an arguments array, which actually it already does anyway. So we actually don't need to make a whole procedure here. So that's actually what I want to do is retrofit this code to not really make a whole procedure. But before doing that, it occurs to me that as a dry run, we can hit this other thing that also just makes temporary procedures, and that is the iteration code. There's this thing that says copy and force infer. All right. This says, hey, we take this is this ridiculous thing that we do where we say every cycle, and actually for the non-looping, we have a simpler version of this. But like if we're looping and we need to do multiple iterations to solve the polymorph, every cycle we say, hey, copy the source procedure, but ignore the body, which I think is what this says, right? And then, do the things, right? And so we generate all these lambdas that we're not actually going to use, right? I think this probably gets called down here. Yeah, is this non-looping? Wait, no, that's the other. This is where we update it every time. Yeah, it's really ugly. Anyway. So I think what I want to try doing. Wait, is that the third? Do we actually call? Oh my God. Need infers to continue. Oh yeah. See, all of this stuff, there's some real complexity in here. That actually, in principle, is not, it can be outsourced to something else. Okay, so here's a call to copy and force infer from, okay, this is the actual make polymorph of called procedure. That's making the final one, right? We do some stuff there, and then we do the bake, which writes stuff into the constants block and so forth. Okay, what about the non-looping? I thought this would have called this as well. I'm getting hungry. We might have to do a break in a bit, and I go to dinner and then come back. Okay. Right, for the non-looping, we just generate a matches array. This is what's so confusing to think about. It is a complicated system. For non-looping, we do not generate waste lambdas. And that's part of the point of doing non-looping. For looping, we do generate waste lambdas. Those are different, actually, from the lambda that is causing this bug. But if I make a facility that just represents the arguments of these waste lambdas, I could also use that same thing for overloads that are theoretical, right? And then I can call a different thing that says, okay, you know what? We like this, promote it to an actual lambda. I think that's the plan. We'll see. Plans don't always survive contact with the enemy, but I think that's the plan. Is this a cleanup or a big fix? This is a medium size, moderately scary refactor. It's not super scary simply because I've hit this system so many times that it's actually kind of tamed at this point. But it's moderately scary in the sense that this is one of the core features of the compiler and really affects a lot of things. And it's real easy to break code by modifying this, you know. Are functions expensive? Not really. These days, I mean, a function is expensive if it doesn't do very much and it's in a loop that gets called very, very, very many times. But that's not very common. So I would not... for most programs, procedure calls are not your primary problem. It's memory accesses that are your primary problem. I can almost guarantee you that you have much bigger things to worry about than what function calls you make. Right? How's the Handmade Seattle talk going? Are they all talking about how their programming language is going to be the best thing in the universe since Cheez-Its? What I really want to know about is what is the memory latency on that new Apple chip, since they have the memory built into the CPU. I'm really interested in how much does that help. Okay. I don't have a dev kit for those. Well, I'm traveling right now, so I don't have dev kits for anything with me. The dev kit that I do have, I have not investigated. I have not done performance benchmarks on. It is across the entire United States from where I am right now. The memory is not built in? What? What are you talking about? They showed the diagram with the memory built in. That's why you can't upgrade it. Did they lie to me? It's not a part of the die. It's built in the system on a chip. Yeah, but I just wonder, I wonder how much that helps. I mean, look, you can't, okay. There's a fundamental thing that you can't get around, which is that at the speed that you could make, say, 8 gigabytes of main memory go with current technology, that's just like a different order of magnitude from CPU clock speeds. So you can't run that memory at CPU clock speeds, all right? That doesn't happen. So, but if it's on the system on a chip, and so you know exactly what it is, and you don't have to, you know, work with different vendor parts of different tolerances and whatever, and you can design exactly for it, I think that could be good. Wow, I look tired. I'm looking at myself in the mirror, and it looks like I really want a nap right now. Do I think we're closing in on a time when super bundled memory management won't be worth as much dev time with all these hardware improvements? No. Nope. Here's the thing. A, it's still easier to make CPUs faster, even though, I mean, it's getting harder over time, but it's still easier to make CPUs faster than to make memories faster. B, CPUs are getting much more parallel, right? Which means either you have to duplicate all that memory everywhere, which cuts down, like, if you have to duplicate the same data structure across 16 CPUs, then you're essentially wasting all that memory, even though you think you're using it, right? You're using it to store the same thing 16 times. Or you could share the memory across CPUs, but then you have performance problems there. You know, if you know, cache coherency kind of problems. So it's just not that easy. What's the process for non-programmers when they want to launch the game? Well, they just update the Subversion repository and then they click on the game icon. But they do, that is a release build that is built by a server. Every time we update the game, it takes the server like 2 minutes because it's polling, but it takes it like 2 minutes to make a release build. I mean, it takes like 30 seconds or something to do a fully optimized release build, and then plus polling time, it comes out to about 2 minutes. So that's what people get when they update the game. The trend is more using internet as a memory. Yeah, that's a great way to make your memory faster, Kappa. We're going to be back in the days of RAM doubler. RAM doubler. Okay. So this is probably going to be a mess. We're going to make another I don't want to call things all the same names. I was going to say asked polymorph parameters. Something like that. We'll call it a proposal. It's a poly proposal, right? Which is when you have people who have they're not generally monogamous, but then they're getting old and they pretty much figure that if they don't settle down soon, they won't be attractive enough to live the poly lifestyle anymore. So then they finally get hitched. That's what this is. I might want to rename polymorph later, but anyway. So we're going to have a source lambda. We're going to have I don't know what else we need. We're going to have to kind of wing it and see what happens. We need those things. I need to make a number for this. This is supposed to be an internal thing that nobody ever sees, so put it at the end. I was watching people play Escape from Tarkov for the past couple days. And it almost makes me want to go back and play that game some more. Almost. Well, A, I'm on a laptop, so that would be terrible. But B, man, that game's brutal. Game's brutal. Okay. Didn't we have some... What? Okay, so here's what I want to do. I want to have a function called make poly proposal. From can't type. Oh my god. So we're going to say what prop is in a minute. When we make the looping, we call copy and force infer, right? Like, it would be great to be able to get rid of this as well, which we may be able to do. The whole reason that's there is because we go and copy all this stuff in order to do polymorphism, but we don't want the body because that's just waste if we copy all that, right? And then this polymorph temporary thing, yeah. Okay. See. I think I want to factor this out. And then here we do a similar thing for the arguments block. Oh, that's different. Blah. Blah, 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 blah. Okay. So this is a procedure right now, but later we're going to want to copy from a poly proposal back to a lambda, which is why this is anything, right? that. Yeah, okay. Okay. Is this source pointer, dest pointer? Not even dest pointer, just dest. Dest. So we're just copying types and doing some grody things. Okay. So here I'm just going to make sure that we allocated that for now. We're going to do this. C++, so we have to tell it about everything 17 times. Okay. Now here use get memory new. All right, so auto prop is get memory new interp poly proposal. All right. Parent equals and prop. Whoops. Arguments blocked up, parent. And then that dot parent type correctly, bro. All right. I'm sure I got a zillion things wrong. Oh. That is a rather dumb one. C++, you have to tell it about everything a million times. Lambda is polymorph result. Wait, what? Okay, this is something I erroneously pasted. That I was going to add a new flag and didn't. I don't know why that didn't revert. Probably because I didn't save the file. How do I handle a problem with the dangling pointers? By correcting my code. Why is the distinction between signed and unsigned integers useful? Because you want to be able to talk about negative numbers, but you also want to store maximum positive range in your numbers. Now, Casey has told me that he thinks it would be better to just decorate all your math operations rather than having those be types. I'm not sure about that, but I haven't tried it. How do you do file module imports? I mean, that is a very, very broad question. You meant from a compilation, POV, jobs, queues, threads. I mean, yeah, as somebody else in chat said, we have a nonlinear compilation model, but it's not about module imports or anything. Because you have these kind of problems. The problems that make you require nonlinearity happen just without any imports of external code. They happen just in normal code. So if you're confused about the problem, you could just try simplifying what you're trying to do down to just one file. What if you only have one file? What would you do? And then can you think of some reason why that wouldn't work if you did that? Okay. And then here, the whole reason we did this was so we could call this here. Dude, I keep wanting to use the word source. I'm trying to make the source engine here. Look at this. Look at all these. I had a source there and a source there. This is very precarious. This just in, source engine. Feature request directive for moving condition outside of a loop. I mean, why don't you just write the condition before the loop? If you want to move it outside the loop, why don't you just evaluate it and then loop? I don't understand why that's a feature request. All right, so this is a terrible C++ error message, but what this means is we had a static assert go off. And what that means is when I added the poly proposal, I did not, there's a place where there's arrays of these that I forget where it is. Yeah, okay, it's going to explain. Yeah, so it's just this static assert. Oh, still. Wait, what? Bro, what? Now we have the fun of C++, which is there's no way for me to know what the hell is going on. How is that not? Oh, because there's a comma. Okay, guys. Everybody who tells me, oh, I just love C++ string concatenation, it's so great, that plus terrible C++ error messages just almost screwed me for an hour. Because this looks fine, but this is the error message. I was about to go dive in and try to figure out what's going on. No, it's that. It was concatenating these strings because there wasn't a comma. All right, people in chat have also said this. But look, I noticed the comma. Okay, so this is not going to run correctly. Because, well, actually it probably will run correctly because we just don't use the poly proposal ever. We do use the copy constants block, so we could see if we screwed that up, which we may have. I'm going to run just all the tests through debug to make sure that that is okay. And I think it probably is. Where's my water bottle? Ah. All right, well, that was not the worst. So do I check this in? Probably. Is there a modification you can make on the compiler that would require you to rewrite a lot of my code base? Oh, of course. Is it safe to write in a language and update the compiler at the same time? I mean, what else would you do? You can't, how are you going to know what to do in the compiler if you don't have code that's using your language? Like I don't understand what the alternative would be to your question. You know what I'm saying? Okay. I think I'm going to run the game again, make sure it works. We're going to check that in. It's not a very big change, but it's a start. And that's a baseline against any further messes that I may make. Great. Okay. No. I kind of wonder if I want to go to dinner and start up again later. It's possible. It's possible. Okay. So we had this looping work lambda. And instead of doing that, we're going to make that a poly proposal. And this is going to be where the mess starts. And it's going to be hard to get back to a working program from here. Okay. Where is it? Looping work lambda. Okay, this is now asked poly proposal, work proposal. We'll call it looping because that just tells us that it's not used in the non-looping case. To a certain extent, what do you mean to a certain extent? Dude, our polymorphism kicks C++'s butt, dude. It's like way more powerful. Okay. Why not using null pointer? Okay, this is a thing people ask all the time. And my answer is because I've lived through so many generations of C++ where they could not decide how the fuck they were doing null that I got tired of it and just used the C version. All right? Because the newer ones don't do anything anyway. And like, even though it's stupid to have null be a macro, like they've just made a bigger mess of it as time goes on. So like, yeah. Like, I'm tired of the incompetence is why I don't use null putter. And also, I don't like this whole thing in C++ of using PTR as an abbreviation for pointer. That just activates my gag reflex immediately. So I do not use anything that uses abbreviations like that, which null putter does. It just makes me want to barf. It's hard to describe why that's a thing. You know how when there's like a couple, like maybe they've been married or maybe they're dating for a long time, and like at some point, you know, the way the guy brushes his teeth gets really annoying to the woman, and she starts being all irate at him all the time. And then the way that she, like, I don't know, something about, you know, some body language or something that she has really annoys the dude, and they all get irritated at each other every day about seemingly unrelated issues. But the thing that they're really irritated about is something unfulfilling in the person's base personality, right? And it's just like the toothbrushing or the body language is just an excuse for that irritation to come out. That's sort of how I feel about null putter, except also it is just a sign. Like the fact that you can't even spell the word pointer is just a sign of laziness and lack of fortitude. So, like, you know, that's all. That's why I use null. That is the story of why I use null. Okay. Now, all right, so we're just going to say we're going to make the force and first separate, and this is going to, of course, be prop equals make poly proposal source lambda. Okay, so that's gone. That is there, that is there, that is there. Um, that is simpler. Okay. All sorts of ways in which it's broken already. Like, there is no infer for this thing right now. So that's going to assert that it's an unhandled expression type. It's going to need to get queued maybe, which it doesn't. Like, yeah, we're messing with things. Okay. Okay. This is just a place for us to leave and come back later. Now, all this stuff here that says lambda is not lambda. Okay. Then we get our inputs. This is like a whole thing that we can ignore for now, I hope. Oh, God. See, this is another place, right? Remember when I was going through and I was like, oh, there's all these copy and force infers. This is like another one. And there's yet another one later. So we're just going to focus. We're not going to rat hole on these yet. We're going to look for the proposal, which I think... Now I've lost track. Let me just see if we use it again. Nope. We're just using that to do these things, I guess. Okay, well, that's great, but we need some other things before this can really do anything. We need to flatten. I think that's it. And then in infer types, I think we just set void on it. Because all we really want is to make sure all these infer, right? Oh, that was the right one. Okay, and then we want to make sure this doesn't go through the pipeline anymore past infer. Do job infer. Wait, I forget now. See, this isn't even parallel right now. Throwback. 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 All right, so here we're just saying, look, you're done. Once you get through infer, you're done. We don't care. Hopefully we don't need things to be in size, but let's see. 6809. Okay, now I think we have a chance of running. I think we will not run, but we have a chance. So I'm saying there's a chance. It is a slim chance. And so what I'm going to do is I'm going to run it, and it's not really going to run. And then I think it's brain break and dinner time. So maybe we'll do a little bit of chat at the end. Oh, like we're not even testing because we just built a release compiler here. So it's going to be break time. Python is fast in terms of productiveness. You can get a lot done fast. That is what everybody says. And then I look at how much they manage to do, and they're historically unproductive. So like, how do you know that you're getting a lot done fast? The thing that is true about Python is it's just like using the Unity game engine, for example. It is very fast to get things on the screen initially when your project is small. Okay? Yes. Do not confuse that with being very fast to develop a large, complex project. Those are different things. Yeah. As I guessed, we do not run. Well, that's going to be something to work on in a little bit. So I think I'm going to take a break. I'm going to get some dinner. And I'll maybe come back and just start hitting the... Like, this is kind of weird because there shouldn't really be a different number of arguments. So I'm not sure what happened. I'm not sure if that's on the first iteration or on subsequent iterations. But like, we're just doing the same thing that our looping source lambda did. So what? Anyway, we'll see. We will see. Compiler talk is over. Okay. Python is fast to show FFT plots and do experimental signal processing. I agree with that first one. The second one, I don't even know. Like, I think if you're doing substantial experiments, you want a type-safe language. Like, you can't... I think if you're doing serious science, it is irresponsible not to have static type checking. I'm sorry. It's just the case. Do you want to know why most research papers do not release their code, even though it's obviously the ethically correct thing to do? It's because as soon as people start doing that, other people will look and see what garbage code it is and how it totally invalidates all their results, and then they'll lose their publication. That's why. People do serious science in MATLAB. They do science they think is serious in MATLAB. All right. And or do it with a great deal more effort than should actually be required. Yeah, the COVID fiasco, exactly. You think dynamic types can only really be defended prior to the development of type inference? I don't think that's true. I think it was still obviously correct to be statically typed before type inference, but type inference does remove one of the major objections. But even without full type inference, you have stuff like auto in C++, which gets you, let's say, 80% of the way there. Like, honestly, auto in C++ is kind of fine for that problem. All right, any questions on what we did here? Before I take a break? Do we have a more sophisticated way of doing type inference? I don't know what you would consider sophisticated. I would say we do more type inference than C++, but in a way that attempts to keep it very simple, approximately as simple as auto in C++. We do not do all this Swift banana cake stuff, for example, that makes the language so slow and hard to understand. How did we get 0? Okay, this is the very first iteration. Like, did I just screw up something very basic? Is this the very first polymorph? Yes. How much is left to do to fully resolve the problem? I don't know. Probably a lot. Like, we're in, okay, so polymorphism in this compiler, the implementation used to be really big and scary. It used to be the #1 thing that I was scared of. It's not really that anymore. It might still be the #1 thing that I'm scared of, but it's been knocked down several pegs, but so has everything else. I'm not really scared of anything in the compiler anymore. So we're down more to like level 2 rewrites instead of level 1. Level 1 rewrites, I'm just making it, this isn't an official categorization, but What I'm thinking of as level 1 rewrites was just like, oh my God, I can't deal with this. I have to do something to make this better, right? Level 2 rewrites is now like, okay, it's kind of under control, but it could be better, you know? And so that's what we're doing. And so I have this idea how to make it better, and I'm just doing it, and maybe it'll be better, maybe it won't. I couldn't tell you. So the propositions are a way to distinguish between untyped polymorph and matched solved polymorphs. No, it's even a little bit more subtle than that. You can have a fully matched polymorph that should not turn into a full procedure because it was only matched as part of an overload with something else that was a closer match. All right? And if that other thing was a closer match, then only that procedure should get compiled, not the other one. Right? So, in general, I'm just making that, I'm sort of making it more explicit that this isn't a real procedure yet. So the poly proposal just says, look, this isn't a real procedure yet. Right? That's all. Maybe I should have called it that. This isn't a real procedure yet. What do we mean by polymorphism here? The kind of polymorphism like you have in functional languages, like standard ML of New Jersey. Question about temporary storage that I showed earlier. How does it present having 2 or more arrays in it and adding to both? It doesn't prevent that. Why do you think that that would be a problem, though? What's the problem with expanding 2 arrays? Is FLR in here? I don't know what that means. Is that a camera? Do we support some introspection? Oh my, you got to go watch the YouTubes about that stuff. Like, we have the best introspection of any compiled language, I'm pretty convinced. I don't know of any language that's ever been made that's better. I mean, there might be one, but I'm not aware of one. Look, I copy constants block, but we never copy the No wonder there's 0 arguments, because we never copy the arguments block, guys. If you want to succeed in the game industry, I think we can just do that, right? Well, not exactly, because now we'll crash somewhere else. 1094. Oh, it is a different place. We got further. Num subs. Well, I don't know what changed about that. Okay. We ignore that now. Come on out here. And let's make sure that's the first one again. No, it's not. It's the second one? Matches wanted. So here we get num subs 2 matches wanted 2. Okay. Actually, this is fishy. Because why would we ever do any more? I don't understand why we're rematching. We already matched. Okay. This is going to need a closer look post-break and post-dinner. What kind of memory layout do I have for ast transformation? You are assuming that I do ast transformation, which I don't really. How do you manage creating and destroying nodes through the pipeline? You are assuming that I destroy nodes, which I do not really. Why would you destroy nodes? You might be reading too many old compiler books. Like, older compiler books have a lot to say about tree rewriting as like a way of optimizing code and stuff. I don't see a point behind doing tree rewriting, aside from some very basic things. In fact, in order to provide certain features to end users at high levels of quality, we minimize the amount of tree rewriting that we do. What am I eating? I don't know yet. How would you know if someone is a good engineer? There's a YouTube video with Casey Muratori and Sean McGrath, where they do a mock interview. And that kind of interview process is a good way to know if somebody's a good engineer. The optimization should happen on back end. Well, I mean, some should happen in the front end. It's just most of the optimizations you care about, tree rewriting doesn't really help you with, or you have to do redundantly in the back end anyway, right? So like, you know, like say you have like A.B.C and you want to minimize computing A.B all the time, right? So like that, if you go look in the Dragon book or whatever, there's like, you know, common sub-expression analysis that happens. But that's kind of bogus and not that helpful because you can't really do common sub-expression analysis in modern programming languages, especially not systems programming languages, unless you have data flow analysis, because you need to know if A changed between one A.B and another A.B, right? And so then you have to like limit that to basic blocks, and then within that basic block you have to make sure that it doesn't, like, it just doesn't work it's not a good way to do optimization. You can concoct scenarios that are really big wins for common sub-expression analysis, like if you just have really big trees that you type over and over, but that's really terrible code, right? Like if you look at some code and somebody has like some expression that is equivalent to like 17 nodes and they keep pasting it over and over again and using it, wouldn't you think that's terrible code? So why do you want to build an entire compiler that is optimized for terrible code? It doesn't make sense. So this is one of these things where people do not sufficiently go back and question the things that they were taught, right? And if things are pointers and stuff is out of the window. Exactly, right? If there is any potential aliasing to anything inside that expression, which guess what? In C you have all the time, you can't do it in the tree. I mean, unless you take it further, you boil the tree down and you make some IR and you do data flow analysis on that, and then you back map that to the tree. I don't know. You could do data flow analysis at tree level, but you would still be doing all the stuff that you do at bytecode level. You would just be doing it in the tree instead. It's just not there's no reason to do it. Like in a modern compiler, you want to get away from the syntax tree pretty quickly, in my opinion. There's no reason to play around with it. Anyway, yeah, someone has linked the interview with Sean McGrath. So there you go. You can watch that. Any other on-topic questions before dinner time for me? Dinner time. Dinner time. Do I want to go to a fancy hotel or restaurant nearby, or do I want to go to like Chick-fil-A or something? It's a good question. It's a good question. It's a good question. Chick-fil-A? Yeah, maybe. Maybe. Is there one nearby? Let's see. If there's one on the island, I might go. I only have 2 bars. Come on, poor connection. Showing limited results. Come on, map. Oh, there we go. Is there one? Oh, there isn't one on the island. There's one off the island. It is how far? 21-minute drive. Do I want to drive 21 minutes to go to Chick-fil-A? I don't know about that. I need to think about that. We'll see. Okay, I'm gonna go take care of my dinner situation and just have a little bit of a brain rest and stuff, and we'll pick this up in a little bit, and we'll just take it further, see what I can do tonight in terms of working on this. So thanks for coming by. We're not going to try to raid anyone tonight because that goes poorly a lot of the time. So we'll just show up again later on.